right, 10.1. We're going to talk about systems of equations, which is super exciting because you guys have done systems of equations in Algebra 1, Geometry, Algebra 2. And it will appear on the SAT and ACT. So you guys have seen this many, many times. We're going to keep doing it. So we've got two ways of solving systems of equations. One of them is substitution. So when we solve using substitution, you want to solve one of the equations for one variable. So you either want it to be x equals or y equals. So you want one of the variables all by itself. Then you're going to substitute that expression into the other equation and solve, and then find your answer and plug that in to solve the other. So ultimately for these questions, you're going to get two answers. You're going to have an x equals and you're going to have a y equals. So example 1, this question is really set up for elimination because we see that if we combine them together, our y's would cancel right away. But the questions say solve using substitution, so we're just going to practice using substitution. So using substitution, we want one of our equations to be either x equals or y equals. Which equation do you want to do that with? Because we could do it with either one.
The top one.
I like the bottom one better. Tomas said the bottom, so we're going to do the bottom one. Just because we're going to add y. The other one you would just subtract y. Or you could subtract x. Doesn't matter. So we have x is equal to 2 plus y. Now once we get what x is equal to, we're going to take that and substitute it into the x in the other equation. So since we rearranged the second equation, we're going to plug it into the first one. So here we have 2 plus y is equal to 4.
I thought that you multiply with.
So 2 plus 2y is equal to 4. What would we do next to solve? Subtract 2. 2y is equal to 2. Lastly, divide by 2, so y is equal to 1. So this is one of our answers, but we still need to find what x is equal to. How do you think we could find what x is equal to? Plug it in. We can plug it into the y there. We could plug it into the y in the first equation. You could plug it into the y in the second equation. It doesn't matter. So x is equal to 2 plus 1, so x is equal to 3. Now when we write our answer, you write it as a coordinate point. Our coordinate point goes x and then y, so it'll be 3, 1. So that is how we write our answer. All right, in example 3, we are using substitution still. Some of these equations are not linear. So looking at the first one, notice how we have x squared. So this is a non-linear equation. What we want to do is get it to be y equals, because y is the one that's not squared. So we always want to work with the equation that's not squared and work with the variable that's not squared either. So in my second equation here, I want to get this one to be y equals. So what could I do first to make our second equation y equals?
Subtract 2x.
I can subtract 2x. So negative y is equal to negative 2x minus 1. Then what? Divide everything by negative 1. So positive y is equal to 2x plus 1. We just changed the signs of everything. Now that we have y all by itself, we can take what y is equal to and substitute it into the other equation. So here we have 3x squared plus 4x minus 2x plus 1 is equal to 7. Does everybody see what I did there? We just took what y is equal to and substituted it into the other equation. What would we do next? Distribute the negative. So 3x squared plus 4x minus 2x minus 1 is equal to 7. We can combine like terms. So 3x squared plus 2x minus 1 is equal to 7. What else could we do? Make it equal to 0. So I'm going to subtract 7 on both sides. So 3x squared plus 2x minus 8 is equal to 0. So we set it equal to 0 because we're going to want to factor. How do we factor this?
First times the last.
First times the last. What's 3 times negative 8?
24. Negative 24.
Negative 24. What are two factors of negative 24 that add to 2?
6 and 4.
6 and negative 4. Perfect. So we have x plus 6 and x minus 4. What do we have to remember to do? If we start by multiplying? Divide. So we're going to divide both of these by 3. So x plus 2 times 3x minus 4 is equal to 0.
X equals negative 2.
Awesome. X equals negative 2 and
3.
x equals 4 over 3. Perfect. Now we have two answers for x. So we're going to have two answers for y. So we have to plug both of them in separately. So let's start with negative 2. I'm going to plug it in here. So we have y is equal to 2 times negative 2 plus 1. Y is equal to negative 4 plus 1. What's negative 4 plus 1? Negative 3. So our first answer here is going to be, what did we plug in for x? Negative 2 comma negative 3. Now let's do the second thing, same thing with the second number. So I'm going to plug in the x. So we have y is equal to 2 times 4 over 3 plus 1. So y is equal to 8 over 3 plus 1. How do we add with fractions? We need a common denominator. So I'm going to change 1 to be 3 over 3. So y is equal to 11 over 3. What did we plug in for x? So 4 over 3, comma, 11 over 3. Don't be afraid if you get fractions here. I think fractions will happen often with these types of questions. Let's look at the one on the bottom. So the directions say solve using substitution, so we're going to keep using substitution. Do we want this to be x equals or y equals here? Y equals, because y is the one that is not squared, and we want to work with the equation that does not have the squared one in it. So we want to get our first equation to be y equals. So what could we do? Add the x. So we're going to add x to move it to the other side. So y is equal to 4 plus x. What would we do next? Plug that into the y in the other equation. So x squared plus 4 plus x is equal to 3. What do we do next?
Subtract 4. Add 3 minus 3.
I'm going to subtract the 3 because we see that we have an x squared and an x. So I want to get it to be equal to 0 because we know we have to factor. So x squared plus x plus 1 is equal to 0. Do we have two factors of 1 that add to 1?
No.
It doesn't factor, so this would be no solution. All right, the next method we're going to do is elimination. So with elimination, we want one of the variables to be the same number, but opposites. So if I have a positive 2x, that means the other equation needs to have a negative 2x. That way they can be eliminated. So elimination, our goal is to get rid of one of the variables. So we need the same number, but opposites. So let's look at our first example down here on the left. Do we have the same number, but opposites? So what do you think we need to do to make them the same number, but opposites? Awesome. We're going to multiply the bottom one by positive 4. Because that way it'll give us a positive 4 because we already have a negative 4. So everything in this equation is going to get multiplied by 4. So I have 20x plus 4y is equal to negative 4. Do not forget to multiply all three things in your equation by the number. A lot of people always forget to multiply the other side of the other side of the equal sign. Just don't forget. I'm going to rewrite our first equation right below it. So I have 2x minus 4y is equal to negative 7. Now do our y's eliminate? Are they the same number but opposites? Yep, so they eliminate. They go away. Now we're going to combine all of our other like terms. So 20x plus 2x would be 22x. And negative 4 minus 7, negative 11. We're going to divide both sides by 22. So x is equal to what? Negative 1/2. Perfect. Again, don't be afraid of fractions. Fractions are okay. Looking at the two equations that we started with, which one do you think would be better to plug this into, the first or the second?
The first.
I would say the first, just because 2 times negative 1/2 is going to get rid of that fraction right there, so you're not having to do as much math with fractions. You can plug it into either one. Just look at them and see which one you think might be a little bit easier for you. So we're going to take negative 1/2 and plug it into the x. So we have 2 times negative 1/2 minus 4y is equal to negative 7. What's 2 times negative 1/2? Negative 1 minus 4y is equal to negative 7. We can add 1 to move it to the other side. So negative 4y is equal to negative 6. What's next? Divide by negative 4. So y is equal to 3 over 2. Perfect. How would we write our answer? Negative 1/2, comma 3/2. Awesome. All right, let's go to the next page. Let's look at the top left one. So here we start off with fractions. We don't really love working with fractions, especially from the start. So is there anything you think I could do to maybe get rid of those fractions? I can multiply the first one by 4. So whatever our least common denominator is, that would be the best to multiply everything by. That way we get rid of 4 from the denominator. What's 1/2 times 4? 2. So this would be 2x plus, what's 3 over 4 times 4? 3y. And then 41 over 4 times 4? 41. So the 4 on top cancels out with the 4 on the bottom. We can do the same thing with the second one. Let's just get rid of the 4 from the denominator. Then we can worry about using elimination to solve. What would I need to multiply by the second equation? 4, because our denominator is 4. So I'm going to multiply everything times 4. So we're just getting rid of the fractions to start. So we have 3x minus 4y is equal to 16. All right, now we can solve this like normal. Let's do elimination. We need the same number but opposites for one of our variables. So what do we have to do?
Multiply the bottom by 3.
We can multiply the bottom by 3. That works. So everything here is getting multiplied by 3. So we have 9x minus 12y is equal to 16 times 3. It's 48. Still don't have the same number but opposite. So what do we have to multiply to the first equation? Multiply the top one by 4. So 8x plus 12y is equal to 164. Now do we have the same number but opposites? Yep, so the y's cancel. 8x plus 9x would be 17x, and that would be equal to 212. Then we can divide by 17.
We're gonna have our calculators whenever we take.
Let's just try. 6 times 7 is 42. So this would be 102, 7.
Says 12.47.
16 was close, but not it. Does it divide?
No.
No.
Yeah.
So we're going to leave it as a fraction. Yep. So x is equal to 212 over 17. Now, that's x. How do we find y? Plug it in. So you can plug it into the original, this one or this one. You could also plug it in. This is the same thing, but we multiplied the top one by 4. This is the same thing. We multiplied the second one by 4. So it doesn't really matter. Any suggestions on what you want to plug it into?
Yeah.
Let's maybe plug it into, yeah, none of them really seem fun. Let's plug it into the first one. So we have 1/2 times 212 over 17 plus 3 over 4 y is equal to 41 over 4. So I can take out a 2 from the top here, and we're left with 106 over 17. Plus 3 over 4y, which is equal to 41 over 4. We're going to subtract 106 over 17 from both sides. So we get 3 over 4y is equal to, what do we need if we subtract fractions? Common denominator. What's common between 4 and 17? Nothing. So let's multiply the first one by 17 over 17. What's 41 times 17? 697 over, what's 4 times 17? What is it? 68. Minus, we're going to multiply this one by 4. What's 106 times 4? 424. And what is 697 minus 424? 273 over 68. We're not done yet. We still have to get rid of that 3/4 in front of the y. So we can multiply by the reciprocal. So multiply both sides by 4 over 3. So it cancels here. Y is equal to 3 actually goes into 273 91 times. And 4 goes into 68. 17 times. All right, so y is equal to 91 over 17. So how would we write our answer? 212 over 17, 91 over 17. So we can do the same thing when we have decimals. How do you think we could get rid of the decimals here?
Multiply by 10.
Multiply everything in the first equation by 10. Awesome. So our new first equation is 31x minus 29y is equal to negative 95. Does anything eliminate?
No.
No. What could we do to make it eliminate?
Multiply either than or negative.
we can multiply everything in our new first equation by -1. So negative 31x plus 29y and positive 95. Now we can combine our new first equation and second equation. So do the x's cancel? Yes. What's negative 12y plus 29y? 17y. And that would be equal to 41 plus 95? 136. Can we divide 136 by 17?
You can.
Awesome. 8. So we found y. How do we find x? Plug it in. So just be super careful since it's y is equal to 8. You're plugging that into the y to find x. I'm going to plug it into the second equation. That way we don't have to deal with the decimals in the first one. So 31x minus 12 times 8 is equal to 41. So 31x minus, what's 12 times 8? 96 is equal to 41. Add 96. 31x is equal to 137. Divide by 31.
4.419.
We'll just call it 137 over 31. We'll leave it as a fraction. So here we have 137 over 31, comma 8. But looking at the notes, so the top, so the top right one, when we work it out, we end up getting, actually let's do it. What can we do to solve using elimination?
You can multiply the top one by 2.
Multiply the top by 2. So our new top equation would be 2x minus 4y is equal to 6. So they both cancel. Great observation. So we're left with 0 is equal to 7.
No solution.
Awesome. When you get something that's not true, the answer is no solution. But if we look at the bottom left one, let's do the same thing. Let's eliminate them. What would we need to multiply to eliminate?
Top one by 2.
The top one by -2. So we get negative 4x plus 2y is equal to -2. When we combine these together, the x's cancel, the y's cancel, so we're left with
All solution.
nothing. And then same thing, -2 minus 2 is 0. When we get 0 equals 0, it's infinitely many solutions.
You just write like all, or it has to be infinite. Either is fine.
Either is fine. Infinitely many solutions.